IoT space. So I'll keep you posted and give you an update on that through my email and through the IoT Texas Meetup site. If you haven't gone there yet, do a Google search, IoT Texas Meetup, and there's a number of IoT meetings listed there every month. With that, let me turn the event over to Sammy Fodil and Ash Mystery so they can introduce themselves and do their presentation as well. Take away, Sammy.
Sammy, we're not hearing you.
Yeah, I first want to say thank you, Ed, for having us present at the IoT Breakfast monthly meeting. I am the founder and CEO of Taubyte, and today I'll be going through some of the issues that we think are important at the edge and how we're tackling those issues. Let me just share my presentation here, and then we can get started. Okay, yeah. So basically, our like holy grail and our like big goal is really to simplify IoT by solving all that software complexity at the edge that I'll be talking about, and might not be as obvious as that actually. Oh. Yeah, so there is today a trend, and this is from Seamster.io. It's a great platform that has a lot of research about edge computing. So I invite everybody to go there and do some research and whatnot. This was originally done by Topio Network and donated to Seamster. So you can see in this table the different verticals, manufacturing, telecom, smart cities, and whatnot, and then the different factors that Topio Network thought were relevant and how important edge computing is for them. And on average, like there is a 30% high requirement for edge across all those verticals. This is just for manufacturing. So you can see here that
Sammy, we've lost your audio.
Yeah, so there are a couple attributes that are we're looking for or people are looking for, and this is why they actually move to the edge. So there is the latency, which is the big thing for 5G, and it might not be a big problem for most IoT application today, but with the in the future with the huge amount of connected devices, it will be, and it will be more and more important, and people will care more about that latency issue as they're educated about it, as more and more devices are popping up on the network. So there is heavy I/O, geospatial knowledge, hyperlocal grouping, data residency, and security. So those are the main attributes that we care about in manufacturing. For IoT, you can see here that it is like the latency is not that critical, but you can see that data residency is, and there is some requirement for security as well. A lot of IoTs today, especially if they have any internet access, are subject to attacks as well. So let's start with the problem. So with this tendency of moving software to the edge, and by edge we mean like really in close proximity to connected devices, development, deployment, and routing complexity rises. and this is a big problem. So how do you deploy software to hundreds of thousands of devices, and how do you route traffic? And this is a big problem. So it is time consuming and capital intensive. The other issue that's kind of like related to the distribution of software, IoT connectivity is very unstable. And when it happens, it can result in loss of data or money. So if for example, you're not able to get your stuff from Amazon Locker, you're like likely to not use that service again. And that's a loss of money for them. So it is very imperative to ensure that operation can continue through unstable links, but also like we need to ensure a consistency. So if the system is made offline capable, let's just keep going with this kiosk example. And let's say like someone takes their package from that kiosk, like we need to make sure that this operation is pushed to the cloud as soon as we have connectivity, and keep like the state of that kiosk like relevant and consistent with the rest of the network. And the main reason like we have those problems and the rise of that complexity is because most people are trying to build software using the traditional centralized approach on top of a distributed infrastructure. So the edge is distributed from this last mile data center all the way to IoT gateways and IoT that are capable to run complex software, and this is a distributed infrastructure. You cannot really build on top of that using centralized approach. So the solution is basically a distributed platform that can extend, or that extends actually from those last mile data centers all the way to IoT gateways and devices. So in the picture here, you can see last mile data centers, and you can see that there is a software stack with the Taubyte logo actually that is on the gateway, on the robot arm, on the delivery robot and camera and so on. So having that everywhere makes that platform and offers that platform or permit this platform to transparently offer this area where software can like dynamically move around and be available wherever it is needed. So basically having all those devices connected with the same kind of software or the same stack, they'll be building like a software defined peer-to-peer network, and that's not new. Actually, what we did is kind of like look at that problem, look at how people are approaching it with the centralized approach, and thought, okay, so this is very complex. How can we solve that? And then like step back a little bit and then look at what's out there. So distributed apps, DWeb or distributed web, or also Web 3.0, and what existed before as well, like what people mostly know, like BitTorrent and like also like Ethereum, which is more like a Web 3.0 kind of thing. So all of those new movements or like what's pushing the new web is distributed software and distributed networks. There are peer-to-peer networks. Like why do you need to send like a message? Like if you're chatting with somebody, why would a message need to go all the way to AWS to come back to you. And there are other technologies that some of you might have encountered, like WebRTC use peer-to-peer. So if I don't know if that's the case, but if Microsoft Teams uses WebRTC, some of this feed is actually not going all the way to a Microsoft server. Is actually just distributed in a peer-to-peer way. But obviously, I don't know how it is made, but that's a technology that is used by many meeting softwares as well. So now that we talk about the problem, I'll introduce like Taubyte and some of what we're doing to kind of like solve those issues. So we think about ourselves as a category-defining platform that enables the true potential of the edge, because we're taking it through a new approach. So we're not like AWS or Azure, where you have this big centralized old thing that just uses containers and centralized technology, and you just deploy that in an IoT device, and then at the end of the day, they're just making you use their cloud resource. They're just making it easy to connect to their cloud, but they're not making it easy for you to develop application or to deploy that application to route traffic. It takes a lot of DevOps to handle those stacks like AWS. Well, I forgot the name. Greengrass, for example. I don't know the name of the Azure one, but those are the ones that can go on IoT gateways and whatnot, and they really do not make your life easier. They're just more as complicated as their related cloud products. So so our product is basically using those principles I was talking about. So it is an embeddable stack, so it can run on servers with a lot of resources, and it can run on IoT or IoT gateways with very little resource. And it builds this peer-to-peer natively distributed software-defined network and offers services through those different stacks. So we offer computing, storage, database ledger, and message broker, and those are basically available wherever they're needed. So if, for example, you need to run some function and it needs to be on a gateway closer to your IoT device, you don't really need to deploy it there. Our stack will figure that out and deploy it automatically in there. So when you update your code, you just push it to Taubyte, and then Taubyte will route it dynamically to where it is needed. And this, we call that like dynamic provisioning of those resources that in our case are all serverless. So serverless compute, serverless storage, and so on. We also have the ability to version and replicate data dynamically, and we can also ensure consistency through high latency and unstable links. And I'll go in some details for a couple of those items. So when you run software on our stack, it runs on a mesh, interconnected nodes. So those nodes can be, again, like a server in a data center, and it could be an IoT gateway on a car, or it could be like an IoT device that's capable of running Linux for now. We might move that to microcontrollers or part of the stack into microcontrollers later on, but for now it really needs a Linux system to run. So yeah, but that could be cameras, like all industrial cameras I've seen so far have run a Linux, for example. So the stack can really be all over the place. So computation will happen where it is needed, and storage as well. That's the dynamic smart part of our cloud. So and there is no master or intermediaries. So in all this network, there is no master node that if it goes down, everything goes down. It's not centralized. It's a fully decentralized architecture, and like there is no single point of failure because of that. Now let's dive into some internals of some of the services we do offer. So I talk about like the fact that it can work even if there is disconnections. So in a decentralized system, when disconnection happens, we call that partitioning. So there is a partition that pops up. So suddenly a system or a subsystem of the whole distributed network become a partition of itself and disconnected from the rest of the world. That can happen if you have like an IoT gateway losing connection, for example. That can happen also at the data center level or at the regional level if there is a disaster or whatnot. In a centralized approach, everything will just stop working. That's not the case for us. So even if there is this disconnection, all the services that we offer will still continue running offline or locally to the partition, disconnected from the rest of the world. So when the connectivity comes back, the node will rejoin and start like resyncing and getting like up to speed with the rest of the world, but also like letting other peers know what happened on its local partition. And basically like the idea is it like uses what we call a Merkle tree. So it's like a Git. So if you have if on Git, when you create when you fork and create like a new branch, and then your branch and the main branch diverge, you can merge them together, and it's easy to do because all the changes are arranged in what's called a Merkle tree. And that's basically what we do, and this is how we can get back to a consistent state all over the distributed network with no downtime and with no conflicts. So to resume all of that, so when you build software on our stack, like they're partition tolerant and they will be always available, and you don't have to worry about that. It's something that we care about, and this is our value proposition here. Now let's go to another service that we offer, which is storage. So we see storage as two parts because we care about IoT. So there is telemetry storage and there is object storage. So starting with telemetry storage, we do a lot of stuff for telemetry. So telemetry is very special because it is repetitive data. So there is a lot of repetition in telemetry. Temperature, for example, do not change much throughout like the day, and relative changes are similar from day to day. Like it's very common that temperature changes are relatively similar. So we do those transformations. So when the telemetry comes into our node, which could be an IoT gateway or the IoT itself or a server that's nearby, it is transformed and then chunked. So so we will transform it in a way where we optimize it, and then we chunk it, and we look into those redundant blocks, and we deduplicate them. So we just link them to the whole thing using cryptographical links. And then we also like store the rest that's not deduplicable, like the new data, and then refer to it with a cryptographical link as well. And then we put all of that object and store it again. So we do that because this new data that was stored in here can be redundant in the future. And this happens locally. And it can happen even if connectivity here is lost. This will keep going and keep happening even if there is no connectivity. As soon as connectivity happens, the node will sync its local data store with the rest of the world and say, hey, I have those new blocks, I have these new objects, they reference those particular blocks and whatnot. And the advantage here, because we use cryptographical links to reference to objects, everything here is immutable, and you cannot alter telemetry that's being generated by an IoT, which gives like some kind of ledger feature to the storage as well. And then next is just straight object storage. So once we get an object to our storage service, which again can be on a server, IoT gateway, or the IoT device itself, it is chunked into equal size blocks, and then those blocks are also will be referenced using cryptographical references. So if the blocks already exist, which is the case here for the green and the pink one, they'll just be referenced. For the new block, which is the yellow one, it will be stored locally and then referenced, and then this will create a new object that references all those previous objects, and they will be stored locally. And that what that gives is out of the box deduplication, because we're not like storing the same data, but it also gives like this ledger-like capabilities, because it's like a blockchain. So it's using like those cryptographical references, so everything is immutable. And if you change one block, it will change the whole thing. So nobody can alter a file that you're storing on our data store or object storage service. And then like in the background, when there is connectivity, all those objects that have been created will be replicated with the rest of the network and synced with the rest of the network. So basically, to resume that, we automatically ensure deduplication of data, but also immutability. So you cannot change data. If you stored some data on our storage network, it is immutable. So, and the reason is because everything is linked using cryptographical hashes. It's like a blockchain. So if when you do a transaction on a blockchain, you cannot change it, because if you change that block, the whole chain will be broken. It's the same thing, and that is a great feature because like it permits you to reference your files or your objects without worrying about those objects being altered. So if you reference, like, let's say a firmware update, for example, that you're sure that that firmware update has not been tampered with out of the box. And then next, I just want to like hint to the future. So as of today, we do not have that many like IoT devices out there, but there are projections. So the IDC projects the number of IoT devices to be around 42 billions by 2025, and I tweaked this number to 42 in purpose, obviously, but it was like 41 dot something. 42 is better, is the answer to everything, right? So, but that's a lot of complexity, and the answer to that complexity, unfortunately, is not 42, but more likely Taubyte. Now I'll go into the Q&A. So we can probably have like 10 minutes or 15 minutes and answer any questions. Do we have any questions?
So I believe everybody is unmuted. So if you have a question, and Gary, correct me if I'm wrong, so they can speak up and ask Sammy directly any questions they have.
Yes, that's correct.
Yeah, and I guess we can also use the chat to post questions if it's more convenient, right?
So as this is being developed, do we have any installations yet? Is this first time or have some experience with this kind of technology?
Yeah. Yes. So actually, we're working on a couple projects with couple companies. And yeah, we're having this project. So one of them, like all of them, actually are involve like IoT and edge computing and inference or some computing being done on the data locally, but also messaging and storage. One of them involves like a ledger service that actually ensure that the telemetry being captured by the IoT devices are were not tampered with. And actually, I was getting to that. So yeah, we published or we set up a public version of our MQTT messaging or like messaging broker. So this is free of use. So anybody that wants to use it, just public.mqtt.taubyte.com, and then you can either use MQTT or MQTTS. There is no authentication. We'll be releasing a private version of the MQTT service and other services as we go. And actually, we do offer early access, but we moved from like having like a public access to the platform to something that's more restricted to businesses. So if you think that we can help you and you want to kind of like explore what we have to offer and you want to like try it early, just reach out to me or reach out to Joe at joseph@taubyte.com, and then we'll make sure to get started. Does it answer the question, Ed?
Yeah.
Cool. Then I'll go back to the. Yeah. Any other questions?
Sammy, this is David M&A.
Yeah. Hey, David. How's it going?
Hey,
Hey, just I know we've talked about some of the benefits of this as far as speed and low latency. Have you quantified that? What can people expect to see as far as improvements in speed and low latency?
Yeah, so basically, so speed and low latency basically are mainly the promise of edge computing. So it's not like something specific to Taubyte. Like all edge computing companies claim that. So and like we're deploying at last mile data centers and data centers that located at the cell tower level and whatnot. So that will give that low latency when it is necessary, which is not the case of most IoTs today. Our value proposition that we think is useful today and tomorrow is really going back to those two features here that we talked about in the problem section. So what we're solving is the complexity of developing, deploying, and routing traffic to this to the software. That's something the main thing we're solving is this. So with us, you do not have to go like deploying code to many places but also like making sure that that the right version is deployed to all your devices and all that complexity that's just like happened because of the huge number of devices or when you're having multiple regions across like the country or across the world. And the other thing that we're solving is really the partitioning problem, the fine problem that's very common with IoTs. So we want to ensure that even if the IoT is disconnected from the rest of the world, when it comes back in, it has this built-in feature to rejoin the network, resync all the data, and get to a consistent state. And you don't have to worry about that on the development level, because if you do, that's very complex. Like to create a software and make sure that, hey, if there is disconnection, I need to store the data, and then one connection to resync, and then download wherever data happened in the rest of the world, and make sure that I'm in a consistent state. And when I say the rest of the world, that could be like really the rest of the world, or could be just local in a factory, for example. If you take a smart factory, everything is connected, everything can run compute. And if you lose Wi-Fi, for example, or whatever you're using to connect your devices, all of a sudden that piece of machinery has its own state. It runs in a partition, and it doesn't really know what's happening with the other or with the rest of the factory. As soon as connectivity comes back in, like that device running the Taubyte stack is going to recompute its state and resync everything and say, okay, now I know everything that was going on elsewhere, and this is my new state, and continue on a consistent base with the rest of the factory, and basically that's the feature. So you get disconnected, everything's still working, that piece of machinery is still working, but when you get this connectivity back, you kind of like just merge your state to the rest of the world, and we're taking all of that complexity out from the developer side. So quicker time to market, less bugs, less maintenance, resilient solution too. So like if someone messes up with the IP addresses, that's fine. When it's fixed, everything goes back to normal or self-healing. if you wish. And then same thing for storage here. So all of that part on the left is happening in the background, and if there is no connectivity, it will still happen locally. As soon as you get connectivity, it will start like doing gossip with all the nodes around and say, oh, what's your state? What's your state? What data you have? This is the new stuff that happened for me and whatnot, and merge and then have a consistent state again. And that happens in the background, doesn't stop what's happening here on the right side. This is still happening. Your software logic doesn't have to care about that. Your software logic always assumes that the system is consistent state. So, and this is really what we're offering. The latency and speed is really a product of the edge itself. Like the fact that you're on an IoT gateway or on the device itself or on a last mile data center, that just ensure that you have those features, low latency and speed.
Okay.
Hey, Sami, Sonal here.
Go ahead.
What are the requirements on the size of the footprint of the edge device itself? You know, what capabilities do you expect to be able to run Taubyte stack on it?
Yeah. So yeah, good question. Our stack doesn't have so you can run whatever you need. So if you need only compute, you can just run that. If you need compute and messaging, you can just run that, and so on. It is very low footprint, and we're actually testing it in a couple of IoT gateways. That includes the Lenovo, which obviously can run the full thing. That also includes in-head network gateways, and we're also like testing it on the Uplink smart camera. If you've seen that product, and that device is quite powerful, so you can run it comfortably, and it can run comfortably on anything similar or close to a Raspberry Pi or anything that can run a Linux. In the future, if there is a need, we're thinking about having some of those parts being used as kind of like libraries, so they can be embedded in microcontrollers. Obviously, probably not storage, but at least you can do like messaging and compute. So you have like a consistent network, and if you want to deploy like code to your microcontroller based IoT devices, you just deploy that to Taubyte, and that could be like that microcontroller could be also like a PLC or something like that, which is generally what those devices are. But yeah, and then if you think, Sunil, if you think that any particular architecture could be interesting to explore, or a particular gateway, yeah, please email me. So it's just sami@taubyte.com, and then we can explore that and see if we can run our stack on that particular gateway.
Sure. And your stack would run on top of the. I'm trying to understand the gateways usually have some either embedded operating system, or it might could be even more primitive, might just have some firmware burnt into it. Your stack would run on top of that, or the OEM would kind of do the whole firmware development on top of your stack?
Yeah, so the answer is really like as I said before, like for now we can run on any Linux capable device. So if that gateway runs Linux, which is the case of most of them, and have like decent like memory, it should be able to run it.
Okay, thanks.
Mm-hmm.
Sammy, this is David again. So as far as, customers engaging with your technology, is it a subscription type thing where they subscribe to be on the network?
Okay, yeah. So we are an edge computing provider, and everything we offer is basically serverless. So so all those like services are serverless, meaning that those are function calls. So if you want to run some part of your code, you call a function. If you want to send a message as a function, do some database operations, those are functions, and so on. And we just like charge per function call and bandwidth transfer. So it's really an FaaS service, charging per usage. So if in a month you use nothing, that's zero. And then depending on what you use, if you do like I don't know, like 1 million function calls, that might be, I don't know, a sub-dollar thing.
Okay.
I don't have pricing in mind, but we can definitely share that with anybody. Just email Joe, as I said here. So he's handling all of that. So any question like about pricing and whatnot, you can just email Joe, and then we can definitely send you pricing. We're very competitive on pricing. If you compare to AWS or Azure services like AWS Lambda and whatever is equivalent on Azure. I'm not very familiar with Azure, but we made sure that we're very competitive compared to them.
Great, thanks.
Yeah.
If you have a question and you're not getting through, raise your hand. There's a button down there in the bottom of the screen to raise your hand, and we'll unmute you in case you're muted right now. Sammy, how long has this taken you to create this? Is this coming from a collaboration with a large group, or is this from some key people that have had this experience that have come together to help create this technology? Yeah,
so we're obviously like we're a startup. We're a small team. As of today, we're 4. That includes me and Ash, and we're working on developing this technology. So we have accomplished a lot. A lot of the services listed again in the one of the slides. A lot of the services here are in these slides. A lot of the services here are fully have been like fully coded, and they're just being tested. And as I said, like we'll be happy to coordinate like any early beta access. Just reach out to us, and then yeah, I mean. We're also raising money to expand nationwide and expand the team and make this like happen and simplify IoT and basically like be a ubiquitous framework for any IoT development. Well, it's very impressive technology. So hats off to you guys for what you've created so far. It's very impressive. Yeah, thanks. Yeah. So and as I said, like it is like the I don't know if that might not answer the question, but it might be good insight. So what's different about us is like we because there are other companies that are like kind of solving some of these issues, especially the deployment and whatnot at the edge, and they're doing it in the mainstream way, where it is still like this, like trying to really push Kubernetes to the edge and to gateways and whatnot, and try to push containers, and then try to figure out how to do the deployment and whatnot. So we just like step back and say, okay, let's see what's out there. So we decided to go with distributed technologies for communication and storage and whatnot, and for compute, which I did not explain here, and that's the part that we're still working on actually, because it's kind of like the biggest part. And we'll do other webinars and we'll get into the details. But basically, the high level idea is like we moved from hardware to VM to containers, and then there is a movement for microkernels. But the whole idea is to have your code and then have all the dependencies around and have that isolated. That's the requirements for all this stuff. And we thought, okay, there is this stable technology that's out there, and that is going actually to replace all your JavaScript in your browser. It's called WebAssembly, and with WebAssembly, it's a stack machine. It's like a virtual machine that runs like a virtual, like a bytecode code, like a JVM, and it's extendable. So if you need to do image conversion or video conversion, you can just load an FFmpeg WebAssembly module. And if you need to do compression, you just load a compression module. And if you need to do messaging, you just load that, and so on. And those modules are very small and can be actually stored. Like if I just go back, what we're doing actually. So, and this is like actually how we're doing it. So if you go back here on the storage level, all those blocks are not just your storage. That could be like WebAssembly modules. So the modules that you need locally will be stored locally and dynamically provisioned locally. So if you need a specific module to run your code, we'll charge your code, the WebAssembly chunk of it, and then we'll charge like the other chunks that represent FFmpeg or OpenCV or OpenCL or whatever you're doing, like AI or whatnot. We'll just charge it, plug it in with the virtual machine, and boom, you have access to those calls and those functions. And the neat thing here, that we'll be talking about that in next webinars. What's cool here is we can actually have, the idea is to have a marketplace for those modules. So if you have a specific software that offers like an edge, you can really create a WebAssembly module and put it into our platform, and then each call to your module will be will be charged for, and this is how you can like charge for usage of your code instead of charging a flat licensing thing. So each, for example, call to some new AI thing that is embedded and can do a great image analysis and inference, that's like a function call, and we can have that as a billable item, and there will be like a ton of modules like that in the marketplace, and people can just use this. Some of them will have this type of per usage licensing or perfection call, and some of them will be free and whatnot. So, but yeah, I mean, that's the big part we're still working on. For the other services, we'll be releasing them like as the weeks goes. So today we're giving this public MQTT access. In about a week or two, we'll be releasing the private MQTT or messaging, because we also support other protocols, and then we'll go on and release and give access to those other services as we go.
Awesome. So are there any other questions out there, guys? This is fascinating technology and potential here is really impressive. So we've been recording this presentation, and if you want to ask a question, raise your hand real quick. But we will. I will send this link out then to everybody that's on my distribution list. If you're not on my email distribution list, feel free to send me an email and ask me to add you to that list. We have over 500 people on that email distribution list, and we have over 2,000 that are members of the IoT Texas Meetup site. I won't clobber them with it, but I'm glad to send the link and contact information for Sammy and his team and for Taubyte to you if you are interested in being on that. I send out reminder emails about 8 days out before our next Third Friday IoT breakfast, and then a day or two before as well to remind people of our meeting. We'll be meeting again next month online, it looks like. Stay tuned. I'll keep you updated as Avnet lets us know if we can start meeting at their facility. But it'll be Verizon Wireless as the plan now. And if you know of other companies' presentations that I should consider, please send me suggestions and whatnot. I'll be glad to look and see if it makes sense to have them speak to us in the near future here. So with that, Sammy, Ash, do you guys want to add any last things to tell the audience?
Yeah, I think first I would say thank you, Ed, again for letting us present the IoT group here in Dallas. That the meeting you run is great, and actually was a great source of connection to us from the first time we attended, which wasn't online actually. So yeah, thank you. And then for any question, so my email is sammy@taubyte.com. Ash is just ash@taubyte.com, and you can also reach out to Joe as well. We'll be happy to answer your questions. If you have feedback for us, we'll be happy to look at it, and actually feedback is important. Like whatever feedback you have, either it's on the technology or use cases or the slides, please let me know. We thrive on feedback. And yeah, that's about it. Any other questions, as I said, just ping us. We'll be happy to answer those questions.
Great. Looks like there's no more questions. So, and it's Sammy with one M, right? S-A-M-Y?
Yeah, S-A-M-Y. Yes, correct. And yeah, it is. Yeah, so it is on the first slide, and actually, Ed, I will share with you the PDF so you can send it with the video as well. Okay.
All right. Great.
Yeah. And for those who registered on Eventbrite, we'll be also sending you the recording and the slides as well.
All right, very good. Yeah. Very impressive. Enjoyed the presentation. Last chance to ask any questions. Otherwise, okay, guys, it was great having you on today. Thanks, Sammy and Ash, and all the best. And we'll talk again soon. See you guys.